Yes, greetings. This is Aloysius Bamundaga. I'm a computer science student, master's, presenting a comprehensive review on the multi-modal sentiment analysis based on multi-layer feature fusion and multitask learning, multi-modal. So multi-modal is a more of, let's say, different models, let's say text, speech, audio that are combined to probably come up with with the results that is combined from the different decisions that are made by the different models that are trained on data that is unilateral, but then it comes to probably achieve the same objective when you join the models. So that's a multi-model system. The multi-layer fusion, different layers are probably counted in between the input and the output layer, and then multitask learning, whereby different tasks are counted in training the model to probably teach it on the different aspects or the data as it's considered, let's say audio data, video data, or let's say text data. So if we go into um, the paper review, this demystifying this, the computational. So the problem mainly was we are trying to review so we are trying to review yeah, a problem. So here we are solving multimodal sentiment analysis. Predicting human emotions using multiple data types. That's a text, audio, or visual data. So here, the challenges approached or challenges encountered when doing this. We find difficulty in extracting meaningful features from different modalities, handling inconsistencies between modalities and ensuring accurate and stable predictions. So these are the challenges that encountered when you use the existing multimodal system architecture that is already existing, or multimodals that already is existing. So these Chinese researchers try to come up with um, solutions or the approach. The approach was a unimodal feature extraction network and also a multitask fusion network. Now, the unimodal feature extraction network was probably brought in to extract strong single modality features. Because first of all, in our challenges, we say that extracting meaningful features from different modalities was a challenge. So this would probably counter that. And then also multitask fusion network. So multitask fusion network is probably the multitask part, less like we probably defined in the what? In the heading, multitask systems. So the MTFN enhances feature interaction and fusion using attention mechanisms and transformers, just like we'll see down below. So if we continue, multi-layer perceptions. So if you look at multi-layer perceptions, so we have different layers. So we have neurons, and then those neurons also have activation functions like the sigmoid and the ReLU. So here, in this paper on review, I analyzed and I realized that these people, or the Chinese researchers, involved the sigmoid and also the ReLU in the different models that they encountered on the data set, or they tried out on the data sets. We shall also look at the data sets that they tried to use, or they used in this paper experiments. So the neural decisions just they transform input features into meaningful sentiment representations. So as the neuron is probably the composition of the what? Of the neural network, just like how you say neural networks and neuron CNNs and the VNNs. So all those GNNs, all those are made of neurons, and these are transformed. You input the features, then the features are generally passed in through the activation functions like the ReLU and the sigmoid to train the neural network to give meaningful sentiments and representations. Then the activation functions. This introduces nonlinearity to capture complex sentiment patterns. Nonlinearity occurs because different features have different weights. So these weights are probably adjusted, like how you see via biases. So the weights are adjusted to improve the model learning and accuracy. So if we go next, so our multi-modal sentiment representation. So as you see here, we have a video here, and then we have to probably weigh and see. We get the visual sentiment, and then we get the text sentiment and then audio sentiment. Then we pass it through the what? Through the neurons, and then these neurons get kind of adjust to see how someone is feeling, how what reflects on someone's probably yeah, sentiment. So the sentiments pass through. So this is a multi-modal system where we have the visual model, the text model, and this audio model. So all those are neural networks that are probably working together. So this is a multi-modal system, as you see. So if we go on the types of activation functions, so we have the rail. So the rail is the rectifier linear unit. So it encounters, so it involves also the back propagation, which does the minimizing the loss function by comparing with the what? With the output, and then also with the with the desired probably output and then the actual output. So it minimizes the loss function. So the lower the loss function, the more accurate the system, or the higher loss function. Then there is a lot of um, work to do there. So the sigmoid is one that is common in classification tasks but prone to saturation. So that's why the ReLU or the back propagation system is applied in ReLU to encounter that. So impact on the network. So different activation functions shape the learning capability of the model and influence recognition of complex sentiments. Yes, so if you continue, now supervised learning. The model is trained on labeled data sets. Yeah, so supervised learning improves, it involves using labeled data sets to probably yeah, to label data sets to probably because unsupervised learning, the data sets are not labeled. The the model has to find insights, or it has to find patterns in that data, in those data sets, to probably come up with something that is probably functional to probably train the model. Now, the supervised learning also helps classify emotions based on multimodal inputs. So yeah, those emotions are the sentiments we're talking about. The multimodal inputs are the visual, the audio, and also the text inputs. So the application. So this is used to predict sentiment polarity. So here, the sentiments are probably positive, neutral, or negative. If someone is probably positive, you will get it from the model will give you something positive about the model system. If something is neutral, the model will give you something neutral. If it's negative, the model will tell you this person's sentiment is negative. Yeah, so we continue. So I talked about back propagation that is applied in ReLU or the rectifier linear unit. So adjusts, so the back propagation is where the network weights are adjusted by minimizing error between the prediction and the true labels. Yeah, that's what I was telling you. So it keeps comparing until the weights adjusted to something that can be used to predict the right sentiment. So gradient descent. Gradient descent is probably also something picked up from machine learning, yeah, from linear regression, but yeah, optimizes weights updates to improve linear learning efficiency. Optimizing strategies. Multitask learning balances Multitask learning balances the intra and inter model function information. Attention mechanisms and transformers are used in the model to mine potential relationships and features. So gradient descent regression also applied in there. So multitask learning yeah, involves intra and intermodal information. Yeah. So attention mechanisms and transformers are used in the model to mine potential relationships between features. Now, application areas: human computer interaction, or HCI, education, um, public opinion analysis. Like I said, all those are involved. All those are involved in this process of application. Yeah, techniques used. We have the transformer-based attention, the convolution layers for feature extraction, and then feature fusion techniques for multimodal data representation. Yeah, so the features are joined together for probably some multimodal representation. Um, so outcome, so the accuracy improved in predicting sentiment from multimodal sources. So yeah, so the different sources like audio, visual, and text, the sentiments are probably improved when it came to the accuracy because they tried this multi-modal system on the different data sets, and yeah, this is what came up, improved accuracy. So apart from that, I think I want to probably thank um I want to thank you for your time, and also probably yeah, watch out for more work to be probably published in this. Thank you.